Alrighty, guys. So we're going to continue on um, with our quadrilaterals unit. And so today's lesson, we're going to talk about trapezoids and kites. Um, Hopefully, it shouldn't take me too long to get through this, but we'll see how it goes. And then, of course, you'll have an assignment posted that you'll need to do. And the way it'll work is because I don't want to bog you down with all kinds of work while we're on virtual. What we're going to do is the day an assignment comes out like this, like today's Tuesday, so this will come out along with the this blank copy of the notes, and if you want them, and um, the homework assignment. It will come out today on Tuesday, and you will have until Wednesday night to finish it. That's 2 days to get it done. Okay, and then on Thursday, a new assignment will come out, and it will be due Friday. Okay, I'm going to leave Mondays blank as kind of like a makeup for anything you need to make up, or just like a relaxation day if you're all caught up. So, all right, let's get started. So, first we'll start with the trapezoid, and there's a couple things we need to know about how a trapezoid looks, because I'm going to reference these vocab words, and I need you to know what they are. So, in a trapezoid, we call the parallel sides, we call those the bases. So this up here is a base, and this one down here is a base. Right? The non-parallel sides, we call them the legs. So this is a leg, and then I'm going to turn so I can do it. This is a leg. Right. Sorry for that random spin. I wanted to write it like that way. So, all right, legs. And then two angles that share a base of a trapezoid, we call those base angles. And that sounds kind of strange. But here's what it means. So the base angles, they both have to touch the base in order to be called base angles. So up here on this top, we would call this one, this angle that I'm putting one arc on, and then this other one, that's a pair of base angles because they both touch that top base. Okay? And then these two down here on the bottom are the other two base angles. So these two touch the bottom base. It's like we could call this base 1 and base 2. So these two touch base 2, and these top two touch base 1. Okay? Now, that's just a general trapezoid, and those names work for all kinds of trapezoids. This theorem specifically is going to work with an isosceles trapezoid. So remember, isosceles trapezoid, we say that's parallel to this, and then the non-parallel sides are congruent. Okay, so it's an isosceles trapezoid. So when you have an isosceles trapezoid, the base angles are congruent. Whoops, here's my paper. So this one is congruent to this one. So we would say angle. Why can I not write at all? Angle A is congruent to angle D. And then we have a second pair down here on the bottom. We would say that angle B is congruent to angle C. Okay? So that's important to know that the angle, both angles that touch the base are congruent. Okay, so let's use that. So this is an isosceles trapezoid. I told you that. And this angle B down here in the corner is 36 degrees. So I want to know angle A, angle C, and angle D. I'm going to write those out just so I know what I'm looking for. Now, we can find one of these really quick. And it should be, y'all should be like angle C. Yeah, because angle C and angle B both touch the bottom base. So using this theorem, angle C is going to be 36 degrees automatically. Now the question becomes, how do we find the other two? Angle A and B, or D, excuse me. Well, remember that an isosceles trapezoid, we have a pair of parallel sides right here. And we can think of this leg as being a transversal. So what's going to happen is this angle, angle A and the 36, are going to be same side interior angles. Now, hopefully you remember from part A that same side interior angles are supplementary. And the same is true over here. Angle D and angle C are same side interiors. So how are we going to find them? Well, remember, same side interiors are supplementary, and so they add up to 180. So if we do 180 subtract 36, that's going to give us what we need. That's 144 degrees. And then if this one's 144 degrees, that means angle D is also 144 degrees. Easy peasy. All right, let's carry on. All right, now we're going to solve for x using those properties. So notice on the original that base angles are the same, right? And then angles on the same side are supplementary, right? 144 plus 36 is 180. And now look at the ones across from each other. They're also supplementary. So that's a thing you want to remember. That if they touch the base, they're the same. The ones that are same side like this, angle A touches base 1, angle B touches base 2, these are supplementary. And then the ones actually across from each other are supplementary. So let's remember that. So look what we've got here. We've got angle B and angle D. They're across from each other. And we know this is an isosceles trapezoid because they tell us this. So this is 26x over here. And then these are also supplementary. So we have to do 26x plus the 102 equals 180. And then we solve. So we're going to subtract the 102. $78. Oh, that didn't work out. Divide 26. We get x to be 3. Okay? Same idea here. We're going to solve for x, and then we're going to find the measure of angle B. So they're supplementary, so 7x plus 30 plus 80 equals 180. Combine like terms, 7x plus 110 equals 180. Subtract 110. Yeah. 7x equals 70. divide 7, x equals 7. Now we'll plug that in. So measure of angle B is 7 times this. What am I doing? I can't even do math. 70 divided 7 is 10. Excuse me, I'm so frazzled. 7 times 10 plus 30. That is going to give us 100 degrees. Phew. Sorry about that. Now, another useful theorem for trapezoids, although we're not technically going to use it right now, is about the diagonals. So notice I have the diagonals drawn in for you. So in an isosceles trapezoid, so let me mark it up that it's an isosceles. And here's our parallel side. Here's the other one. So in an isosceles trapezoid, something happens with the diagonals. We say that the diagonals are congruent. Right, that's only for an isosceles trapezoid. The other trapezoids, it doesn't work. So our diagonal AC, we say is congruent to DB. Okay? And then we have one important theorem about a kite. So let's write this as a kite. Now remember when we have a kite, it kind of looks like this. So we say that the short sides are congruent to each other, and then the long sides are congruent to each other. Right? And they also have a property about their diagonals. So we say that the diagonals of a kite are perpendicular. What's perpendicular mean? It means that two lines cross to make 90-degree angles. So right here, all around here is 90. I'm just putting two of them. Okay? That is important to know because you're going to be asked to find some angles inside of this kite, and they're almost always going to give you one right here, and you have to know that when the diagonals intersect, it's 90. So let's see how we're going to do that. Now, this first problem actually doesn't use the diagonals yet, but I want to include it because sometimes you're asked about angles in a kite, and this is the one and only time we get to talk about them. So let's label what we know. The measure of angle M is 90, and P is 54. I want to find N and Q. Okay? Now, we could go through the big long process here of drawing the line, the segment MP, proving they're congruent. No, we're not going to do that. I'm going to give you the hint, okay? Every time in a kite, every time, the angle that is between the two congruent sides, so the angle that's between the side with one tick and the side between two ticks, okay, so that would be angle N. This angle and the one across from him, okay, these two across from each other are always the same, okay? So let's make a note of that. The two across the shorter diagonal. See if we drew the diagonal in right here. that's shorter than the other one. Okay, so the two angles across the shorter diagonal are always congruent. So the measure of angle N is going to equal the measure of angle Q. But how do we find it? Well, you should have mentioned this in part A, but if you have a kite, which is a kind of quadrilateral, we should know that all four angles in a quadrilateral add up to 360. So we're going to do 360, subtract the two we know. What is that going to give us? That gives us 216. And now because both of these are 216, we're going to divide 216 by 2. And that means that both of them are 108 degrees. All right? Please remember this tip up here, that the two angles across from each other on the short diagonal are always the same. I can't tell you how many times that comes up, and you're going to have to know it. All right. Now we're going to use the diagonals in that theorem. So we said that angle MOR, so let's find that. MOR is 32 degrees. I like to label. Now we're going to find these other ones. So the measure of angle ORM, so follow those letters, ORM, that's right here. Where is this angle at? Well, it's at the intersection of the diagonals, so it's always 90 degrees. Because that theorem says the diagonals are perpendicular. So I'm going to mark that. Actually, I just did what I did there with the box. All right? Now, we want the measure of OMR. OMR. Well, that's right up here. And if you'll notice, it is part of this little triangle right here. Okay, we already know this is 90 and that one's 32. And we know that all three angles in a triangle add up to 180. So what we're going to do is we're going to do 180 minus 90 minus 32. And that will give us 58 degrees. So this one up here in the corner is 58 degrees. Okay, now I want the measure of angle ROH. ROH, which is this piece right here. And there's another convoluted long way to figure out how to find it, but I'll just be straight with you. Let me tell you what we do. So wait a minute, I gotta think about this for a minute. Yeah, I think this works. The diagonal actually cuts this big angle in half. So ROH is part of this big angle, and so we know part of it's 32, so this other part is going to be 32 degrees. Okay, so this one's also 32 degrees. And we know we can find that because we know this is 90, and then this one's also going to be 58. So we can use that same 180 trick to get the 32. All right. Okay. That's all I have. So that's all there is for trapezoids and kites. So please make sure you watch the video in its entirety and complete the homework assignment. And if you need help, let me know. So again, this video will be attached on today. We're Tuesday's assignment. The assignment will actually be due Wednesday, so you get 2 days to do it. And of course, if you're doing it on Wednesday, you can reference back to this video on Wednesday. All right? If you need help, let me know.